Okay, so here's another example of a system of equation word problems. We've got that a local gift shop sold bags of candy and cookies for Halloween. Bags of candy cost $5.50 and bags of cookies cost $4. Okay, and the sales equaled how much? 50. Okay, now let's first discuss, how do I know this is a system of equations? Well, that was one scenario, and then I get this second scenario that says there were 3 more bags of cookies than candy. That's my second scenario. So I got 2 different scenarios, so I know it's a system of equation word problems, right? Now what I'm going to do first is I'm going to define bags of candy as the variable x and bags of cookies as the variable y. Now the easy part here is setting up the first equation. Okay, the first equation would be $5.50 times what? X. So $5.50 times x plus $4 times what? Y. Good. $4 times y, and my total is $50 spent. $50 spent. Now scenario 1's easy. The harder portion is this portion where it says there were 3 more bags of cookies than candy. Okay. Now when they start talking about there's more of this than that, okay, the easy way to do it is go ahead and write x equals y. Okay. And then we're either going to have to add 3 to one side or subtract 3 from the other side. Okay. Now let's think about this. And what you're trying to do is you're trying to balance out this equation x equals y. You're trying to make it fair on both sides. Okay. So it says there were 3 more bags of cookies than candy. So the cookies have 3 more. So to make it fair, I need to either take 3 from the cookies to make it even, right? Or I need to add 3 to the what? Candy. Does that make sense? So I've got a scale, and cookies and candy on the scale balance out, right? But they're saying that the cookies have 3 more, aren't they? So the cookies section's heavier. So I need to either add to the candy 3 or take 3 away from the cookies. Does that make sense? So which would you rather do? Would you like to, since the cookies have 3 more, would you like to subtract 3 from the cookies or add 3 to the candy? Subtract 3 from the cookies. Now which variable represents, now wait, did you say subtract 3 from the cookies? Which variable represents cookies? Y. So what we'll have to do is subtract 3 from y. Or, if I wanted, I could have added 3 to x, couldn't I? You understand that's the same thing? And you see how you just take your little balance, and since it says there are 3 more bags of cookies, the cookies is a little heavier, isn't it? So I need to either take 3 cookies away, or I need to add 3 candy, right? And so what we did is we took cookies, which represented by y, and we subtracted 3 from it, didn't we? And now you've got your system of equations. Now tell me this, how would you like to solve this system of equations? I'd love to use substitution also, because right here, x is already solved for, isn't it? What's x? Y minus 3. Alright, so what we're going to do is we're going to take y minus 3 and we're going to substitute it in for x into the other equation, right? Because we're saying right here x equals y minus 3. So since that's what x is, I can plug it in for x. So I've got 5.5 times y minus 3 plus 4y equals 50. And now I need to distribute 5.5. And so 5.5 times y is 5.5y minus 5.5 times 3 is what? 16.5. Good. Plus 4y equals 50. And now at this point what I'm going to do is I'm going to combine like terms. 5.5y and 4y gives me 9.5y. And at the same time, I need to get this negative 16.5 on the right, don't I? And so I'm going to add 16.5 on both sides. And so I've got 66.5. Is that right? And then I'm going to divide by 9.5 on both sides. And we should get a whole number because it's hard to, well, no, you could split up the bag of candy. So what does y equal? 7? And so what we're saying is we have 7 bags of cookies, but we don't know how many bags of candy we have, do we? Well, I can take my y equaling 7. You see my y equals 7? And I can put it in for y right here. What's 7 minus 3? 4. And so what we're saying is, okay, we've got 4 bags of candy and 7 bags of cookies.